Okay. All right, so let's get going then. So welcome everybody to the 1:30 session. My name is Eric Green. So it is my intention to provide something both interesting and useful to you in the next 60 minutes. So I'm going to talk about enterprise fitness design, and I'll define those terms as I move along. But the idea is in large engineering organizations to be intentional about designing the system in a way that allows us to measure and manage and make better decisions. So that's kind of the thrust of the talk. To provide a bit of structure for the talk, there are three kind of primary areas that I'd like to cover: the what, the why, and the how. So the what is going to be concentrated on around a problem statement of intangibility with knowledge work in general, and specifically as that relates to large organizations in an enterprise setting. That problem becomes fairly wicked at that scale. The why, I think there's a need for kind of a technical understanding of this and to have techniques to make the system tangible and to help underscore the cost of this problem in large organizations. And then the how, what I'm going to do is share some implementation examples and observations that I've come across in recent years working with Fortune 100 companies and look at kind of scaling patterns of Kanban systems, integration patterns, and sort of how to go about thinking about demand architecture. So that's kind of the structure of what we're going to do here today. So a little bit about me. I'm a little bit of an odd bird, I think, in the community, as I haven't traditionally come from IT. I spent 16 years at a company called Advanced Micro Devices. I don't know if any of you are familiar with that, but that's the only really competitor, x86 microprocessor competitor to Intel in the world, and has been for some decades. So I cut my teeth in lean manufacturing in the early 90s, and actually was operating Kanban systems in semiconductor 10 years before there was an XIT case study. So been doing this for 25 years and kind of cut my teeth on lean. Sort of everyone had to read Womack and Jones. It was like required reading, you know, back at AMD. So that's a picture of a microprocessor fab, if you've ever seen that. So it's a pretty interesting environment. You see those robots on the monorail. They carry around the product to the different process steps, and they get various chemical treatments and so forth to build the integrated circuits. So my work there at AMD was basically developing factory automation and process control systems for that environment. So there's certainly a tangible aspect to the picture that you see. You can see the inventory moving around on the robots. You can see the equipment. It's all physical. It's all tangible, right? So that's very different from a setting in knowledge work where everything is invisible and intangible, and it's just ideas that are living in our head. So that's kind of how I cut my teeth. So 17 years at AMD, did some time at eBay and Borland. Anybody recognize the name Borland? Any of the old people in the room? Yeah. So eBay and Borland was where I kind of had an epiphany in first using the Kanban method with teams, and I figured out that I could sort of double throughput by implementing these practices. And I was kind of shocked at the time that I thought there was some error that I had made, but it actually is repeatable. And then spent some time at Bazaar Voice doing a transformation of their R&D department using static and the tried and true practices of the Kanban method. And then in later years, spent time at Capital One a couple of years at FedEx, and really the experience that comes through in the talk is really concentrated on those two companies working across dozens of organizations across the US. Then spent some time at Accenture SIQ, and I've recently landed at Adobe back in my hometown of Austin as Chief of Staff doing lead transformation in their commerce group. And accredited Kanban trainer at KCP, and have been a member of this community for a number of years. So that's kind of my background, and so I bring kind of a unique, I think, perspective to applying this stuff in knowledge work. So let's start out with a problem statement. So while things are intangible, they're just ideas in our head, we're not able to measure them or effectively manage them. When policy lives as tacit knowledge in people's heads, oftentimes we don't all agree or have the same understanding of how we make decisions and how we manage risk and how we manage flow. So we want to make these policies explicit and make the work tangible and have a concerted effort to model the system in a way that makes it measurable. If we have informal working agreements and things are kind of loosey-goosey, I've found that that's really not a sound basis for transformation or really sustainable improvement. So we have a problem with things that are intangible and they're just ideas in our head because we can't see the robots moving the product around. It's just ideas. To compound the problem, we don't explicitly design and implement a coherent system structure in the enterprise, in large organizations, because it's very hard to do that. It's a daunting problem. It's a wicked problem in my experience. It requires a lot of energy, a lot of communication, collaboration, and engagement with the people in the organization. So a lot of times we just don't bother to model the system in a way that enables us to measure and visualize it because it's just too big, the system. So we have a kind of a compounded problem there, and that results in us making bad bets. There's a lot of operational economic waste that lasts for years, and that's very painful. Oftentimes we just get used to that pain and we just kind of settle for living that way for years. And so I think this slide is really kind of about a wicked problem. So to underscore that just a little bit, on the left, you can see the inventory there. You can see its physical inventory. It's subject to the laws of physics. In fact, if something falls from the top there on that guy, he dies. That's how real the inventory is. But on the right side is knowledge work. That's all the inventory when we're dealing with knowledge work. It's just an empty room. It's just air. It's just maybe ideas in those two individuals' heads there. Maybe I have 20 backlogs with 200 items each. It's just, you can't see it, you can't feel it, you can't touch it. So it's very hard to manage because it's not physical. So that's just the problem of intangibility and why we want to make things tangible, is because we need something to wrap our arms around, something to touch and to measure. So the aim, what I'm trying to accomplish with the talk is a couple of things. One is I want to stay theory-free, all right? So the things that I'm sharing and the patterns and the observations that I'm sharing are things that I've seen in the field or implemented directly myself. They're not coming from a textbook. And here we're staying true to the pragmatic, actionable, evidence-based guidance mantra that this conference represents. I want to motivate a whole system technical understanding of fitness through domain modeling and system implementation. That's kind of the overriding objective for the talk, is to motivate a technical understanding of the work, and even getting down to the level of modeling the work in a way that you might be akin to domain modeling or object modeling, but being very explicit about what are the attributes or the observable traits that we need to measure to understand our health or performance as a business. So we need some discipline there, I think. We'll understand fitness through the metaphor of evolutionary biology and identify areas to consider, specifically in an enterprise setting. And then I'm going to illustrate some Kanban system integration patterns built and observed in, as I said, Fortune 100 organizations across the U.S. over the last 6 years. So hopefully there'll be some things here that you can take and go and do something with the very next day that you're in the office. So some questions that come to mind that we can help address with the content here is, how do we define organizational fitness, health, or performance, whatever term that you want to use? We need to be explicit about how we define those terms, and specifically what are the attributes that we look at to discern the level of fitness. And then, can we draw a domain model that folks agree to that comprehends the whole system being managed? And this has been an insight for me in working with a lot of enterprise clients. Is one of the things that I'll do is I'll just draw a sketch on paper of what the demand architecture looks like, what all the feedback loops are, what are the roles involved, and create a little ecosystem map. And then I take that around, and everyone I talk to, I show the picture to, and I get them to correct what is wrong about it. And I just evolve this drawing, just napkin kind of drawing, over time, and I've found that that creates a shared sense of reality of what the system actually is. And at this level, it's very crude. It's just a hand-drawn sort of, this is what our world looks like, this is how the demand flows, and I just socialize that with a lot of people and get them to poke holes in it. And at the end of the day, that helps to create a shared sense of reality of what the system is that we're actually managing. So the domain model I've found to be particularly useful in this area. I think it's important to start with questions that need to be answered or decisions that need to be made when it comes to measuring things. A lot of times I think, look at what are all the different data that we can evaluate and that we can look at. What are all the metrics that we have? And I think that's kind of backwards because a lot of times we measure things that we don't actually use to make decisions. And sometimes we misuse data in a way that is not helpful or leading towards evolutionary change. So this is kind of a classic BI approach to designing a BI system. You always start with what questions an executive or a manager wants to answer. And then from that, now we can go and try to identify data sources and metrics that give insight into answering that question. But I found that it's not particularly useful to start with what are all the things we can measure. It's really what decisions do we need to make, what questions do we need to answer, and then from that we go look for metrics and data sources that can help provide an insight into that. So I see this backwards most of the time. It's like we can measure all these things and we create this big a la carte menu of metrics, but no one can really answer the question, what problem does it solve? What decision does this enable? So let's start with that, is what I'm saying here. Start with the question. So a couple of assumptions as I go through. So visual management and limiting WIP, to me, are just flat table stakes in knowledge work management. And why me as a KCP, I have to always be mindful not to judge the person that I'm trying to help and to try to work around their emotional resistance. Maybe it's because I'm in my late 40s. I've really come to the notion that if we don't visually manage the work and limit WIP, it's almost willful negligence. I mean, we have been doing this for a long time, and we understand that when we don't limit WIP, we create waste. And when we don't visually manage our work, we just don't have a level of coherence there. It's all storytelling and emails and meetings and hallway conversations, and you can't actually run a business like that. So individuals and interactions is fine as long as they're supported by effective processes and tools. It's not one or the other. You actually need both. But I really think this is table stakes nowadays. So I think it's critical to take a whole system view and understand the whole system that we're managing, not just a board, not just one system, not a subset of boards, but what does the whole architecture look like, and how do these Kanban systems interconnect with one another? How do they integrate with one another? Do we have policies in these systems that govern the integration between them? And most of the time the answer is, I found no. We just have a loose sort of understanding of how the Kanban systems are intended to work together. And how the feedback loops, how we design those at every level of that demand architecture. I think it's important to be very intentional about that. And again, that's just part of that system model. And this idea of enterprise, lean agile scaling or transformation, David talked about it a little bit earlier. I don't actually believe that we can succeed in that endeavor with an intangible system. I think we have to make the system tangible and codify it in technology or on the wall, but it has to be explicitly defined. Otherwise, you can have all the roles and ceremonies and fancy artifacts that you want. If we don't have a system we can all go to and look and see the same picture of reality, it's not going to work, in my experience. So this term fitness, right, we leverage the metaphor of evolutionary biology for this. And I recently found this term adaptive radiation, which is kind of interesting. It's the process by which species evolve rapidly to exploit an empty ecospace or a niche within the environment. And the classic example here is Darwin's finches, right? So there's 14 species of finch bird in the Galapagos that have all carved out a unique niche in that environment in different islands. And the primary kind of fitness criteria for these birds is their beak. So the shape of their beak, you can see the one there has a very strong beak for crushing nuts or whatever he needs to do. And the other ones are more surgical, kind of fine-grained instruments where they collect small insects or what have you. And so these birds have adapted to these different niches in their environment, and they've carved out a space where they thrive. And so this is the metaphor that we're kind of looking at here. The fitness criteria for these birds are their beak dynamics and dimensions, and you could measure different aspects of that and understand why they're able to be fit for purpose in their particular environment. So making the intangible tangible at a single, within a single system. So this, for those of you that maybe are new to the conference or new to Lean Kanban, this is something for you. But so I really like to talk about and explore the mechanics of these systems. So, okay, we have a workflow there, kind of concept to cash. We've got options, an option pool on the left side. If you prefer the term backlog, that's fine. The only problem there is that the term backlog infers that we've committed to everything already, which we haven't in most cases. All right, so it's an option pool. And then we have the upstream part, the discovery part. We take the raw material of an idea that is intangible, and we refine that idea down into something that we're going to justify spending money on, right? We're going to commit to that, and that's the act of investment when we do that, right? So the upstream part, David Hughes talked about the importance of this yesterday, and this is absolutely spot on. The upstream part of the system is incredibly important to be able to ensure that we're working on the right things. And a lot of times in agile kind of settings, we have the idea that we have a backlog and we do work and we have some superhuman product owner that keeps the backlog in good shape. And that generally is not the way that it works out. If we have a big backlog, what we have is a bunch of liability. We have a bunch of stuff to keep track of and to understand what's in there, and a lot of times that is just pure waste. Right, so this upstream part of the board is crucial to do the options development and ensure that we're working on the right set of things that we want to deliver next. So this board has three kind of classic phases: upstream, midstream, downstream. The options development is the upstream part. The execution is the midstream part, and then downstream we have the release management activities and the validation of the value hypothesis and all these things, right? So now we put some limits on there, and we've got a definitive profile of the limits there. So we've got 12, 6, 6, 3, 3, 3, 3, right? So literally creates the shape of a funnel, and that forces us to make valid prioritization decisions in creating that funnel. And David talked about it yesterday, David Hughes, the filter on the front end, right? We want to filter things out when it's as cheap as possible to do that. And this upstream filter allows us to avoid opportunity cost. It allows us to eject things that we should not be wasting our time and money on. And that's another reason that it's critically important. But the upstream, it takes the raw material of that idea and makes it into a tangible thing that we understand and can invest our money in. But you see the WIP profile there that kind of whittles down the list to just a small set of things that we're doing at any given moment. We have our multi-phase commit there. The first dotted line is the commitment to build something. The second line is a commitment to deploy something. When we commit to build something, we don't know exactly when it's going to be deployed, right? Because we have to do the work first. But by the time we kind of, implement something to where we're code complete, then we can queue it for release, and then at the point that it crosses that second phase commitment point, we know, or we should have a very good idea of exactly what date this thing is going to be released on, right? So multi-phase commit there. And then we can do some capacity allocation, right? If we want to put limits on the rows there to hedge risk and ensure we have capacity for certain types of work based on demand analysis, based on our understanding of the arrival patterns of these different types of work, we can allocate WIP limits on the swim lanes themselves. And so that's capacity allocation, right, on the horizontal. And then we put the work up there, and then voila, right, now I've got my warehouse and I can see all the boxes stacked up. So this is making the work tangible and really providing a level of coherence and decision making so that we know what the heck we're doing. So I use the term spatial awareness with clients. So risk management is about spatial awareness. I have to be able to see things side by side to make a trade-off decision. I have to bring one forward and leave one behind, right? It can't be an email. It can't be, a conversation. I have to see the options in front of me, and I have to intentionally sacrifice some and let one go forward. It's a spatial problem, I think, to do this well. Everything on the board costs money, and not everything is guaranteed to generate any. So another insight in the course of my work over the last several years is to understand fitness through domain modeling of observable traits. Right? And this domain modeling term is kind of a classic technical analysis of the system, and maybe it's because I come from semiconductor manufacturing and software development. That's my cognitive bias. But it has been helpful in these environments to do this domain modeling and share that with folks. So I've got some kind of examples here of kind of domain models or object models, and these are different concepts that I've used in the past. Maybe you can sort of look at this later, and maybe there's some things in here that would be helpful to experiment with. It's fine. If not, that's also fine. But the idea here is that we have a hierarchy of demand, right? There's an enterprise portfolio item that breaks into organizational portfolio items, that breaks into capability epics, that breaks into features, that breaks into stories. So I have that chain of content there, and it's explicitly defined, the relationship of those things. And then if I drill into a story, the story has different attributes that I care about, that I may want to filter and coalesce data sets on. The type of work, the class of service, the type of value, how we're going to measure the value, cost of delay, dependencies, system dependencies, team dependencies, NFRs, right? There's a lot of different options there. But these attributes, data attributes, allow us to filter and analyze certain groups of data to enable forecasting and understanding how we're doing in these certain areas. If we don't take the trouble to explicitly define these data attributes, then everything is sort of subjective, and we're not always using the same terms when we talk about the notion of priority or options development. So this is saying let's explicitly define these data attributes of the work so that we can have something to base our decision making on, something tangible to base decision making on. So this example is looking at the concept of value and risk and the dimensions of each. So how do we understand value? What does it mean? What are the dimensions of value? I could have customer value, learning value, like if we're doing kind of speculative research activities, we're not delivering new functionality to a customer, we're trying to gain some information, we're trying to learn something, and that will inform something that we may do in the future. Are we trying to develop internal capabilities like test automation, build automation, those kinds of things the customer never sees, but there's value for the organization, and so we want to be explicit about what type of value that is. Same thing with risk. What are the different dimensions of risk that matter in our business? Cost of delay, the shape, the magnitude of cost of delay could be something else. Like what happens if we incur the cost of delay? How painful is that? Do we go out of business? Do we just suffer some discretionary spending impact? Is there some political, egg on the face? What is the risk that we're trying to manage? And again, being explicit about what those parameters are. Economic risk, political risk, reputational risk, technical risk is all different kinds of risk. And it behooves us to explicitly define what we're talking about when we talk about risk. And then you can use those data elements to then visualize, do a risk profile or a value profile. And then you can visually compare the work items to one another based on how deep they are or how much of an impact there is in these different dimensions. And then you could orient sequencing and prioritization based on a discussion around these shapes and how they're different. Maybe we care about the legal risk right now, so we're going to do those first. And we're going to do the technical risk ones later, right? So this is parameterizing the work to be able to visualize risk or value to drive a decision around what we actually do and when we do it. So a Kanban system, this is just breaking down the elements of that, right? And that would lead to the board representation there. So there are classes of service. There's the standard taxonomy of four standard types. There can be others. The states of the board for each state, does it have a limit? What's the exit criteria? And being really crisp on that exit criteria is, again, it's table stakes, right? It's a way to work in a consistent way so that we all understand, when I move this across the line, what does it mean? When we don't have explicit exit criteria, invariably there are things that are going to come back and we're going to churn on them and people are not going to agree that they're done. So it behooves us to be very crisp on the exit criteria and to model that into the system in a very deliberate way. The thing there on release, the exit criteria is validated by a user. So a lot of times we deploy things and we stick a flag in the ground and we say mission accomplished, and meanwhile that thing is sitting and no one is actually keeping cares or is using that functionality, right? So that's kind of a vanity metric. So it's important to have a validation step at the end where we explicitly go talk to the customer and say, this thing that we delivered to you, is it helping you? Does it solve a problem? Do you care? A lot of times we don't do that. So metrics to enable decisions. This is kind of breaking down the idea of a product and the internal execution in our engineering or IT group. So how do we measure fitness of the product? How do we measure fitness of the organization? Right, with a product, we can measure things like NPS, revenue, stickiness, escape defects, support calls. These are all telling in terms of how effective our product is in the market. And so they're things that we want to understand and comprehend. Organizationally and execution-wise, now we look at more things like speed, efficiency, so what percentage of the time is something being worked on the board versus it just sitting there waiting or blocked. We have a lot of evidence by now to clearly suggest that the lion's share of time that work items stay in the system, they're just sitting there waiting and nothing's happening to them. So the implication there is that we can optimize the way of working all day long, but if we have a flow efficiency of 10%, meaning that only 10% of the time we're actually working on the item, we can optimize the way of working all day long and we're not going to impact the lead time hardly at all. So we need to understand the efficiency. Predictability is predictability of time to market, right? Is how long is the tail on the lead time distribution for a particular class of work. The longer the tail, the less predictable we are, right? All the risk is out on the tail. Throughput, how many of what type of things do we deliver per unit time? Like, are we 2/3 failure demand and 1/3 new features, or are we 1/3 failure demand and 2/3 new features? We need to know that as we go through time to understand the ratios. Blockers is one of my favorite topics, because blockers are common cause delay that the organization is usually completely blind to, because we don't really measure blockers very often sufficiently. So blocker clustering is well and good to sort of cluster stickies based on type of blocker. That's a good start, but I think this begs for a bit more analytical treatment on the blockers, and I'll show an example of that in a minute. And then code probably goes up with product, but how many times do we regress the build, what number of tests, how frequently do we merge to master, those kinds of things can be very useful as well. And then again, this kind of modeling exercise leads to a high fidelity dashboard of something that we may look at in operations review, for example, to understand our fitness for purpose. But there's an underlying kind of modeling activity that is typically done prior to the graphs. So demand architecture is key to scaling. I mentioned this a little bit earlier, and the term that I use is demand architecture. And again, we're talking about big organizations that have multiple cascaded levels of systems that feed each other and integrate with each other. I don't see a lot of really talk about this. So I'm trying to bring this to the fore. So I'm sure everyone's familiar with the concept of a release train metaphor here, right? It looks aerodynamic and sleek and fast, doesn't it? It's not. It's that. It's a big ball of spaghetti when you really look inside. So this example is from a large client a couple of years ago that stitches together the demand dependencies between teams. So each node in the diagram is a separate team. And one of the things that I do when I do static is I do a dependency analysis, and the teams will put themselves in the middle and draw a picture of all the dependent teams around the edge. And so through going through and working with about 8 teams in this case, I went and stitched all those graphs together, and this is the picture that it made. So when I put in a request to this release train for something to be done, some subset of those arcs get lit up, and I have no way of knowing which ones get lit up and what the critical path is. I have no way of comprehending that. At least with the picture, we can see the glorious complexity, and we can at least have a more realistic understanding of how that work is being done and what the dependencies are. So I'm advocating to go to this level of understanding. And I know maybe this is making your stomach turn a little bit looking at this diagram, and you're thinking, man, that's a daunting thing. I'm not doing that. That's the point, actually. Then we're going to suffer under these conditions until we put this front and center and say, this is our system, did you know? So a couple of scaling patterns, more scaling patterns here. This is a very simple example. So this is really not an enterprise kind of configuration here. This is even smaller than that. But so what we're showing here is a program, Kanban system on top that does demand shaping for a subset of teams, right? And the epics that live in the program system get broken down into stories that flow through those individual team boards, and then you can have a shared service there that's servicing the teams directly. And notice the direction of pull is down. It's another concept that big organizations have a problem with, that the direction of pull is down, right? So the nodes at the bottom, the effectiveness and efficiency of those systems dictates the speed at which the epics move across the upper level. And when we don't understand this concept, we just push, and coerce people to do more and work late and cut corners. But the direction of pull should be down. But we're shaping demand for a set of teams here. This is a similar example, but now we've got a portfolio system on top that is doing demand shaping for a program. And then the program is doing demand shaping for multiple service level team Kanbans. And we've got a filter on the front end of these boards. The integration, there's policies between these boards that say, when I'm in the portfolio, when I get to a decomp step, that means I drop down to the program and I work with my colleagues to break down the requisite features. And then when the feature moves across, I go down and work with the team to break down the stories. And so it's all connected up and it all works together. If there aren't policies that explicitly integrate the systems together, then it's just a mess. We don't know, the state of the parent item is not going to be reflected necessarily by the state of the child items, and so we never know what the status of that work is. We have to integrate these systems together. And then if we have a coherent taxonomy defined of different types of work, then we can understand capacity allocation here and the ratio of different types of things that we're working on. You can have planned portfolio, unplanned portfolio, planned local and unplanned local as some categories that a leader may care about. Like, what are the ratios in the work that we're doing? Are we doing 80% unplanned local? Well, that's a problem for the portfolio, right? So we need to kind of comprehend this. And it all comes down to instrumenting the work to be able to create a graphic like that. So now we'll scale out a little bit more, a little bit larger pattern here. Again, we've got the portfolio on top. We've got multiple programs underneath and a set of teams underneath each program. And these are very small implementations here. The ones that we see in the wild tend to be significantly more complex, but there's only so much real estate I have to work with on these slides, so I try to keep it simple. So now we have demand shaping at the portfolio level that's going across multiple programs, right? And then coming down, we've got some shared services down there. Maybe that's UX and enterprise architecture at the bottom, servicing teams from multiple programs. That's a common pattern. And one thing that I've found to be useful when we're looking at a system like this is to have the concept of a reference implementation, which is a vertical slice through that architecture, which is we're going to get the portfolio and the program level set and then be able to get that working with a set of teams, but we're going to do one slice of that, and we're not going to try to go for all this all at once. We're going to get the reference implementation working reasonably well, where it's stable, and then we'll engage with the other programs to do something similar in a way that's contextual to them. But I certainly would not try to go implement this whole thing in one shot. I would just get the vertical slice stable, and then we would share the learnings and work contextually with the other programs to scale horizontally there. Okay, so this is exploding out a little bit more. Now we've inserted a large solution layer. For those of you that are familiar with SAFe, that's a system of systems construct there. It's a huge system. So we've got a company level portfolio or a parent portfolio that's feeding multiple large solutions, and underneath each large solution there can be multiple programs. And then multiple teams underneath each one of those, and shared services at the bottom. So again, it's just another variation of this demand architecture that we've been looking at. And then there, the reference implementation would be, that vertical slice there, and then, we scale out once we get that stable. So these are just patterns, right? I'm not saying that, your system should look like this. I'm not saying anybody's system should look like this. I'm saying that these are real patterns that I've helped implement with clients and how we've gone about that. And I realize how daunting this looks. Like you're probably thinking, man, that's complex, and I'm happy coaching teams, and that's fine. But when we're talking about scaling and we're talking about really big organizations, I think at some level we have to really take a look at this and understand what the structure of this actually is. And then we're going to scale it up one more time. This is the Uber scaling example of there's an enterprise portfolio on top. We have multiple companies now down below, operating companies. And then underneath each operating company, then you've got your kind of large solution program team service structure. So like a FedEx would be something akin to this, where FedEx is it's a parent company of FedEx Corporation, and then there's a bunch of operating companies underneath that, and then each of those operating companies has its own portfolio. So you have multiple levels of portfolio here, and it gets pretty complex. All right, so kind of bring this all together in a working model of a pretty basic portfolio example. See and operate the whole system. I mentioned the whole system concept earlier. I think it's really important. It's not just a lean principle of see the whole. It's explicitly design and implement and operate the whole system. So we come down and again, we send that demand to the program level from a portfolio, and we shape demand for these teams and shared services. And then there's another one, and there's another one. Now, coming to the point of the domain model, right, this is demand is this system picture. We can overlay multiple systems on top of this. We could overlay a social network, a reporting hierarchy, feedback loops. Like the system is multi-dimensional here, but this is the demand architecture. And then a practice that I found to be useful is getting clear about what the roles and responsibilities are in each system, right? Because we don't come in and dictate the roles, right? The roles, in my experience, are always contextual to the organization. Even if you have safe roles and scrum roles, there are still roles that are specific to that company that will always be there. There's never a pure play, agile role kind of concept in these big organizations, in my experience. So I think it's good to just clarify who makes decisions, who's responsible for what in each one of those systems, regardless of what the roles are. They could be project manager, business analyst, that's fine. But let's be explicit about what those folks do, what decisions they make, how are they helping. So a RACI model can help there. And now we explicitly define the feedback loops that overlay, right? We've got strategy risk review, operations review at that program level, right? Multiple teams coming together, telling the story with data about how things are going. Boardwalks, different teams. And so now we're getting a deeper understanding of what the system is, right? You can imagine if we don't take the time to codify this and to draw this picture, this is all just a mental model that we have. And I guarantee you that the mental model between individuals is not going to match when we're contemplating this kind of dynamics. So to keep adding on, now if we have our work kind of instrumented in a way to measure type, then we can do this kind of ratio capacity management exercise where we understand in each system what is the ratio of type 1 work to type 2 work, how much portfolio demand are we working on versus architecture runway or versus failure demand. But we have to instrument the work to enable that kind of understanding. And then we have some lead time metrics or some fitness metrics that associate with each system so that we can understand how quickly things are moving through. And so the point of this is to show the different layers of things that we can add to a system like this to gain a deeper and deeper understanding of what is actually happening. Because again, when we just sort of conceptually have an understanding of this and there's no tangible definition of it, then it's guaranteed that we're all not going to be thinking about this system in the same way and what's important and how it works, quite frankly. So a little bit on measurement, fitness measurement. So I've got a collection of heuristics that I've used, right? I'm not saying that's right and you're doing it wrong. I'm just saying that these are things that have helped me, as I've, trekked up the mountain there a couple times. Foster a culture of objective transparency, right? A lot of times can be an allergic reaction to transparency in organizations. And I think, trust and transparency, they're codependent, right? You need both for any one of them to be successful. So cultivating a culture of objective transparency. Objective transparency means we need to see everything that's going on, but we're not going to judge people. We're going to simply embrace the reality of what we see, and we're going to make decisions to make things better. So that's what we mean by objective transparency. Agree on what fitness means, or what performance or health or whatever term is used in the organization. We need to be explicit about what that term means, what we're measuring there, in terms of business agility. The term business agility and this whole business agility movement of late is interesting to me, because it's like that's where we started, and now there's a whole new thing called business agility, and that was like the original intent, but now it's a new shiny thing, business agility. So now we have business agility consulting and coaching, and it seems odd to me. I thought it was always about that. So don't start with data, start with the questions and decisions that we need to make to run the business. And then from there, back into what do we need to measure and what metrics are available to help provide insight to answer those questions and make those decisions. A lot of times we start backwards there. We start with, here's a bunch of data, and now let's kind of, have a knee-jerk reaction to what we see on a daily basis. Start with few metrics as possible, right? Keep only if helpful. Sunset metrics, right, when they're no longer useful. Get rid of them. They're in the way. Things that aren't helping you solve a problem, that don't help with efficacy of what we're doing, get rid of it, regardless of where it comes from, right? There are no sacred cows in any of this. It's all about being pragmatic and having evidence to show that you're able to solve a problem with whatever practice that you happen to be using. Avoid vanity metrics, common sense, right? But even the number of items deployed is a vanity metric. Even the bottom line on our CFD, the cumulative delivery rate, is a vanity metric. Because if we can be delivering, a lot per unit time, but again, if nobody's using those things and they're not solving a problem for the customer, it's a vanity metric. It looks like we're killing it, right? Because we have a steep slope on that cumulative delivery, but meanwhile, 20% of those features are being used, right? So when a metric becomes a target, it ceases to be a metric, right? So it's just something that we need to, I think, be vigilant and mindful of. As soon as you set something as a target, then lo and behold, people are going to hit that target one way or another. And we may lose visibility in the process. So just some heuristics that I've kind of gathered in my backpack along the way. All right, just some basic examples of kind of fitness measurements that I really use quite a lot. So, and I think this is good for any folks that are kind of new to the conference and new to the community. So speed is definitely a fitness indicator. If you ask a customer, do you want me to deliver fast or slow? I doubt that they're going to say slow. They always want it faster, right? So that graph is just a run chart. It's showing two different types of work there. And you can see the variation and the volatility in the lead times. And then there's one treatment that I like to do to the data is put a linear regression through that data, just fit a straight line through it to see the tilt of the data. If it's tilted up, it means we're getting slower. If it's tilted down, it means we're getting faster. If it's tilted down, it means we have evidence that something that we're doing is actually helping us deliver faster. Right, so that's how a team can use this data when they start to use WIP limits or get crisp on exit criteria or whatever it is. Right, we always want to overlay those changes on a graph like this to see if there's an inflection point, to see if the signature of the data changes after we implement the new policy. So a lot of times we look at metrics like this, but I don't see a lot of annotation of these charts to here's where we started limiting WIP, here's where we changed the policy, and see if we can see some relationship there. Predictability is just our good friend, the lead time distribution graph there. And I have another example of that coming up. But that's telling us how predictable we are. What's the spread of variation? How much risk do we have inherent in our process? How long should I expect to wait for my item to be completed? Right, I can get the answer from this. Again, assuming that I have a way to coalesce this data set as one type of stuff, right? Because if it's mixed, this is bugs and new features and spikes and whatever else. If that's all just jumbled together, I can't really use this for forecasting. It's just a multimodal, lumpy, distribution. So there's the example of the blocker analysis there. That's a stacked bar looking at frequency of different types of blockers over time. And this is incredibly powerful in my experience. One of the things that we did at Capital One a few years back is we went and beefed up all the blocker codes in version 1, and then we pointed Tableau charts at the API, and we generated these graphs for the blockers for a whole department. And then when we brought the leadership of the department together, we could see everything that's causing invisible delay to a set of teams. And then we could go off and drive improvement activities to bring those bars down. This is normally completely invisible to the organization, this delay in the blockers. And I don't find it common that teams are really rigorous around marking things as blocked and giving appropriate reason code and analyzing that data. So we're just missing out when we don't really analyze this data. And then there's our good friend, the CFD diagram. So that tells the story of the execution as well. So this is just a lead time distribution graph with the cumulative probability or percentile overlay line, right? This is old hat to probably many of you in the room. For the new folks, this is something just great to have in your back pocket as you go through your career. It's been one of the most useful tools that I've picked up from this community. But the idea is that the y-axis is frequency or instances of occurrence. The x-axis are the spectrum of lead times. So it's to say that, like the mode there, the tallest peak is we've had 3 work items that took 22 days. And then the tail goes out to 100-something days there. And the roughly 90th percentile is at 61 days. So when someone comes and asks, how long is it going to take to deliver this item, I can answer that probabilistically and say there's roughly a 9 out of 10 chance, 61 days or less. They may not like that answer, but that's the answer. And if we have to estimate things, it behooves us to bring our estimate and look at this graph and say, well, where does my estimate fall? My estimate happens 10% of the time, or 1 out of 10. That's a risky bet to make if I'm making that commitment to another person. So I don't want to make that commitment. And if we do make the commitment, you're going to have to do something extraordinary to get it in that time frame, because 9 times out of 10, we don't deliver in that time frame. So this is incredibly useful just to sanity check any estimation practice that's there and to probabilistically set expectation about how long things take. And notice that we've filtered this data by a number of attributes: the type of work it is, the class of service, the order of magnitude and size. I'm not advocating some quantum physics with Fibonacci numbers, just some broad buckets there, because if I have 2 things on a board and this one is 10 times the size of this one, that's a problem, right? So I don't want to let the 10x'er into the system. So type of value, type of risk, right? We've filtered this data set to a very specific set that I can analyze and forecast. If we don't have these dimensions defined, then I can't actually do that forecasting, because I just have a big set of data that's just kind of munged together. And this is a tool that I built a few years ago. This is Monte Carlo simulation. So on the prior one, we were predicting for how long an item would take. Here we're predicting how long the whole batch is going to take based on historical data. So what it's doing is, so we've got some work that's been completed of 3 different types: 28, 78, and 145. And then those little spark line distributions are the distribution graph for lead time for that particular type. You can see the different shapes there, the Weibull distribution. And then I can go and say, okay, if I have 8 at the top, 11 in the middle, and 22 of the bottom, that's what my current backlog or batch looks like. How long would it take to burn off that work? And then I can run a simulation to say, I've got 6 workers, or I'm going to work 6 at a time, and I'm going to run the simulation 10,000 times. I'm going to burn off the backlog 10,000 times, and then what does that distribution look like? And then that's the distribution curve you see there. It's saying that the 90th percentile is 107 days. So that would be a way to understand how long it's going to take to do a whole project or a whole batch based on historical data. And this is not something that you just run once and you bank on the result, right? You do this iteratively and you validate assumptions with this data. It can be quite useful, but you don't just toss everything out and just rely on this, in my experience. All right, some tooling things. I think, a lot of KCPs will say start physical first, right? It's a good way to work out your system and work out the nuance of what that needs to be before going to a tool. And it actually, when we think through the constraints of a tool, I think it convolutes our understanding of the system because we're thinking through artificial constraints. So if we do this physically, then whatever you can think in your mind, you can design it on the wall. You can develop a far more sophisticated system on the wall than you can implement in software. So this is really a nugget here of a way to get started for a single system is to do it physically. You can tear the tape off, you can move things around, right? It's cheap and easy to do that. And here, kind of another dissatisfaction of mine. For God's sake, let's stop settling for shoehorning our stuff into an ALM tool that doesn't work for us, right? I mean, this has been bothering me for 25 years, this problem. But it's still, I see it every day almost. That we're just going to shoehorn it in, whatever the configuration gods, however they set up the tool, we're just going to shove it in there and we're going to make do. Well, that's going to lead to frustration and economic waste for years. So I think enough is enough with shoehorning into these tools. And then the scaling method or framework is not going to save you. It's just going to give you the delusion of control, right? It's about the system and making that tangible. Okay, real quickly, so there's a static model here. This is my static hat model. It's my variation on static, which notably I add a dependency analysis and a policy analysis. I found to be quite useful. So that's another nugget. I think, what is Mike Burrows calls this the hidden gem of Kanban. Well, I think that's accurate. And then there's a model here for just some broad steps that I will take in big organizations to kind of model out that system. Domain modeling, model the taxonomy for the whole system, understand the dimensions of risk and value, the integration policies, how does this system integrate with this system? That should be policy. And then tooling, configuration, and change management is there red because that's a bear, but it's something that we have to address, I think. All right, summary and takeaways. Look at the whole system by modeling the whole system. I mean, we have to get beyond just this lean principle of see the whole. That's just some ideal, but we have to kind of get down to brass tacks and we have to model the system to comprehend it fully. Without making the system tangible, scaling and transformation do not work, in my experience. Domain modeling can be an effective tool. Good old-fashioned domain modeling, just breaking down the data attributes of the system, I think can be very helpful. Use a reference implementation, right? If we have to scale across multiple departments, do one vertical slice through the architecture, get that stable, and then work contextually with the other programs or other departments to do the same thing, but don't try to do the whole thing in one shot. And then pick a pattern as enabling constraints, right, and not the solution, and use feedback loops to guide evidence-based change management. And so with that, I think I'm right at time. Thank you for your attention.